So you've got a question from the required practicals, and it's about reading data. What's the best way to do it? Roll that graphic, let's find out. Hi, I'm Paul, this is Science That Sticks. In this video I'm going to be talking about required practicals and data. The first of which is you're going to have some sort of table of some description. If it's chemistry, quite often there's going to be a time component. And there might be a volume, a mass, a colour change, whatever. Let's go with a mass change here. Now, let's also make an assumption that this time happens to be the time taken for a reaction to complete as the mass of a reactant is increased. Everything else is kept the same. So what you've got is you've got a conical flask with a reaction taking place in it, and they add a solid into it. Okay, the more solid they add into it, the faster the reaction will get, until it gets to the point where all of the reactants are completely used up, and then it's as fast as it can ever get. Okay, so what we're going to do is we're going to start with 1 gram, 2, 3, 4, 5, 6, 7, and we'll go to 8 grams. And let's say that we've got a time of 20 seconds, and we'll make it a little bit faster each time. So we'll go to 20 seconds, we'll go to 15, we'll go to 12, then 10, and then we'll keep it at 10 all the way along. So that's 1, 2, 3, 4, 5, 6, 7. That's badly done. But I don't care that it's badly done, because it's the reading of the data that's important. It is not necessarily important that you are able to see it perfectly. Now, you might be asked to write a conclusion about this, okay? In which case, you would state that as the mass increased, the time of the reaction decreased. Fair enough. 1 mark. You would then state that beyond 4 grams, the time taken for the reaction remained the same. It was constant. 2nd mark. It might ask you to explain that. If it does ask you to explain that, then you've got to make the reasons clear and state why this is happening. Well, the reason for this is simple. Once it reaches 10 seconds and the reaction is finished, that means that whatever was in here that's not the solid that's been added is completely used up at this point. So everything here is in excess. There's no more reaction to take place. So it tops out, in this case, at 10 seconds. This is a really nice way of explaining something. So when you look at a graph, you don't just say, for example, as X increases, Y increases. If this is what the graph says, that's absolutely fine. But if there's 2 marks, have a look at any mathematical correlations. If X doubles, does Y double? Okay? Is it proportional? Is it inversely proportional? Do not state that you have positive correlations. What if it's doing that? Okay? You'll have to state something about that. If it's a rate reaction graph, you'll have to talk about the speed of the reaction here, here, and there. Okay, so make sure that you state at least 2 separate things when you are looking at the data. Okay, practice as much as you can. And until next time, ladies and gentlemen, stay cool. Bye for now.